All right, this is example 2 from section 6.4. This is example 2 that is not in your book, but it's similar to the one in your book. Watch the video link. Just click on the link on the ebook. Buy example 2 to watch example 2 if you need it. But this is just another example, very similar. So let's go for it. It says find the coordinates of F, the midpoint of OC. Here is OC, and we need to put F as the midpoint. So right there, this is F. And show, so we need to find the coordinates of that. What are the coordinates of F? So F, the coordinates are going to be, well, if it's halfway between O and C, and this is the x-axis, so we're looking at 0 to 2p. And if it's halfway, then it's just going to be p. And it's on the y-axis at 0. This is the coordinate for F. That's pretty simple. Now we need to show that FD is parallel to BC, this whole thing right here, BC, all the way up there. And show that it is half the length of BC. Now, in order to find out if two lines are parallel to each other, you need to find their slopes. If the slopes are the same, then they are parallel. So let's find the slopes of FD. So the slope of FD, and let's find the slope of BC. The slope formula is y2 minus y1 over x2 minus x1. You guys memorize that. We're going to use this all the time. Okay, so now let's do FD. So F is P0. So our y is 0 minus the D, which is it's halfway to B, right? So B's coordinates are going to be Q and R. All right, if it's halfway to that one. Okay, so 0 minus R, and then P minus Q. All right, and that equals negative R over P minus Q. I know it's weird with letters, but it's the same principle, same way with numbers. Okay, that's our slope. Now we'll do BC. Let's see, C is, the y is 0 minus 2R, 2P minus 2Q, and that comes out to be negative 2R over 2P minus 2Q, and we can, the 2's are going to cancel out. This is going to equal negative R over P minus Q. So the slopes are the exact same. So this whole process here is your answer to show that FD is parallel to BC. Okay, now I'm just going to write it. The slope is going to equal this. I'm just going to put it over here for now because I need to erase and make space. We need to prove or show that FD is half the length of BC. Okay, so that means we need to find the distance from here to here and from here to here, and that is the distance formula. This is another one you guys must memorize. We use this all the time. x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So the distance of FD is going to equal the square root of, we're going to go from the x, which is 0, minus the x over here, which is q squared, plus y is 0, y is r squared. And that's going to equal q squared plus r squared. I hope I did that right. I didn't do that right. I was looking at these 0, 0 here. F is P0. I'm sorry. So the X is P, like that. So we could distribute or factor out all of this stuff, but let's leave it as P minus Q squared plus R squared. Let's just leave it like that for right now. Sorry it's at an angle, I'm standing sideways. Okay, now the distance of BC. All right. Now let me circle this, box this one up. This is our distance for FD. BC. All right, we've got 2P minus 2Q squared plus 0 minus 2R. 20 squared. Now we can factor out a 2. And factor out a 2. And that 2 can come outside because, oh, I'm sorry. You can't factor out a 2. You know why? Because it's squared. It's squared. That means it's going to be, you're going to be factoring out a 4. But I did that right. I better double check that. Yeah, I'm so smart. Okay. Now, we can bring out that 4. So let's bring out the square root of 4 out here. And you're left with P minus Q squared plus R squared. And the square root of 4 is 2. And then everything stays the same inside. I think you can still see that now. Okay, so square root of 4 is 2. I can't go any further than that. Notice it's the same here, but there's 2 because BC is twice as long as FD. FD is half of BC. So this is my way of showing that FD is half of BC. This is all part of the answer, okay guys? That's all part of the answer.